Alright, let's talk about the properties of logarithms. So, for properties, if b is greater than 0, our base, and our base does not equal 1, then these properties are true. So let's talk about them. Log base b of 1 equal to 0. Now the reason that is, if I were to write that in exponential form, so our base is b, and then whatever the log equals to, our exponent, which is 0, it equals to 1. Now, base can be any, or b can be any base. So if our base was, say, 2, 2 to the 0 power equals to 1. So if I say that 5 is our base, and 5 to the 0 power is 1. So with any base, to the power of 0 is always 1. So whenever you see a log with a base number of 1, then it's always going to equal to 0. Now, our second property, log base b of b equals to 1. And the reason is, if I write that in exponential form, b, which is this one right here, to the power of 1 will equal to b. So pretty much the same as what over here is. So again, any base such as 6, so 6 to the 1 power will be 6. If it was 9 to the 1 power, then it would be 9. If it was 3 to the 1 power, it would be 3. So whatever the base is that's powered by 1, it will be the same base, which is why log base b of b will always equal to 1. Now for the last property, if we have log base b of b to the x power equals to x, if I were to write that in exponential form, I would write these two, so our base b to the power of x equals to whatever is inside the parenthesis, so bx. So you can see here that bx is on the left side, bx on the right side, and they're equal to each other. Well, that's true, because whatever equals to each other has to be the same on both sides. So when you have log base b and it's the same base to the power of x, then it's just simply equal to x, meaning the exponent. So if it was log base 5 of 5 to the third power, then simply it's going to equal to just 3. If it was log base 6 of 6 to the second power, then it would just equal to 2. And again, one more is like log base 7 of 7 to the fourth power, then it would just simply equal to 4. So these are the basic properties of logarithms. Now let's talk about properties of common logarithms. So what I mean by common logarithms is that in here we have log with no base. It looked like it at first, but let's talk about it. So when x equals to a real number, then these properties hold true. So our first one is log 1 equal to 0. Now when you see a log with no base, then that means it's basically an invisible 10. So let me rewrite it for you. So log with base of 10 of 1 equal to 0. So the reason I'm bringing this up is because when you're working with calculators, scientific calculator, or the TI-83s, 84, when you're typing in log, it doesn't give you that option to type in the base. It's automatically set to a base of 10. So again, scientific calculators, TI-83s, TI-84s, so any calculator like those, they're already pre-programmed with a base of 10. So when you have, again, just log, then it's an invisible 10. So it's log base 10 of 1 equals to 0. And just like the other properties discussed before, if I rewrite it as an exponential form, so 10 to the 0 power equals to 1, which is 2. So any number to the power of 0 equals to 1. So let's move on to the second property. Log of 10 equals to 1. So again, if I were to rewrite it with the invisible base, so again, when you see a log with no base, it basically means invisible 10 as the base. There we go. So now we have log base 10 of 10 equals to 1. And if I write that as the exponential form, then 10 to the 1 power will equal to itself, 10, which is true. So whenever we see a log of 10 equals to 1, it's always going to equal to 1 for this type. Now, our third property, again, it doesn't have that base, so it doesn't mean that it's not there, it's just an invisible 10 of 10x equals to x. And then if I were to rewrite that in exponential form, then 10 to the power of the exponent x will equal to whatever is inside here, 10x. So 10x equals to 10x. That's true. Since it has an equal sign, therefore both sides must be the same. The left side has to be the same as the right side, vice versa. So this is why log of 10 to the x power is always x. Now again, x could be any exponent. So if it was log 10 to the 5th power, then it will all equal to 5. If it was log of 10 to the 2nd power, then it will equal to 2. If it was log 10 to the 150 power, then it will equal to 150. So again, these properties, when you see something like this, then automatically you would know what the answer is.